Here I want to develop the idea of how to use grouping to factor trinomials now that have three terms. Excuse me. So let's start by relating a polynomial to its factored form. Okay, so these two polynomials here are equal to each other, and this is a trinomial and this is its factored form. So here's its factored form. If you want to verify that they're equal, the way you could do that is by multiplying all of this out, and you should get this. So let's go through that process really quickly. Let's multiply 3x by x and we get 3x squared. Let's multiply 3x by negative 3 and we get negative 9x. Let's multiply 2 by x and we get positive 2x. And multiply 2 by negative 3 and we get negative 6. Now here's what's curious about this. Of course, this still equals 3x squared minus 7x minus 6. But this is actually an interesting step here. Okay, so let's go ahead and finish it off here. 3x squared minus 7x minus 6. Okay, this direction, when you start with the factored form, let me get rid of some of this. This direction, starting with this form here and then multiplying it out and simplifying it, is called simplifying. Okay? Simplifying. And this process of starting with this guy and going up this direction is called factoring, right? Because we're trying to write it in its factored form. So it's almost the exact reverse of this. So how does this work? And the key to this is the middle step here. Okay? Whenever we look at this middle step, notice that the negatives, so we're working from bottom to top here to try to factor. Notice that the first thing that happens is negative 7x is rewritten as negative 9x plus 2x, thus creating 4 terms instead of 3. And at this moment, when you have 4 terms, you use factoring by grouping to finish it off. Now, the interesting thing is, where did the negative 9 and the 2 come from? Well, that's the hardest part of this process of factoring a trinomial by grouping, is creating the two numbers. For example, I could have used negative 8x plus 1x, right? Negative 8x plus 1x is negative 7x also. But if I want to factor this polynomial with 4 terms by grouping, the only two numbers that will work are negative 9 and positive 2. So let's determine how to find those two numbers. Okay? And this is what it comes down to. The numbers on the ends of the polynomial, 3 and negative 6, 3 times negative 6 equals negative 18. Okay? So, sorry, I missed my negative there. Equal negative 18. The numbers that go in the middle, in this case negative 9 and positive 2, also have to equal negative 18 when you multiply them. Okay? So that's how you find these numbers. So the two numbers that go in the middle have to multiply to give you the same thing as the numbers on the outsides of this, and they also have to add to give you the number that you had in the middle. Okay? So one more time, if you start with a polynomial, let's erase all of this now. If I were trying to factor this, I would try to find two numbers that multiply to give me 3 times negative 6, which is negative 18, and two numbers that add to give me the negative 7. Okay? Maybe I shouldn't write equals, maybe I should write 2. So when you try to do this, look for numbers that multiply to give you negative 18 and then check to see if they add to give you negative 7. So negative 1, positive 18, they multiply to give me this, but they add to give me positive 17, so those won't work. So 1 is the first number that goes into 18, 2 is the next number, so one of these two numbers would have to be negative, because they have to multiply to give me negative 18. So if I choose negative 2 and positive 9, that gives me this, but it does not give me this, right? They add to give me positive 7. But if I switch the signs around and use 2 and negative 9, then I've got it. Alright, so those are the two numbers I would use to split my middle term.